Hello, I'm Gui,
I'm a fifth.
And I'm Long.
and you're listening to Kopi Overflow, a monthly podcast about software development. So by the time this episode comes out, end of August, we will be nearing our 1 year podcast. So episode 12 will be 1 year, right? Since we're doing this once a month, and then 12 is 12 months, so that'll be a year. I can't believe we actually done this for a year already. So as part of that, I think it would be nice to do our 1 year anniversary kind of episode with a mailbox episode. So when this episode comes out, we will have links, I think everywhere, to a link to a Google form for questions. So if any of our listeners have questions, feel free to fill in the form. We'll go through, we'll sort them out, and we will basically answer the questions. We'll include an end date for the form as well so that we can prepare right before recording the episode. Yeah. And also, since we've been doing this a year, I can't believe we don't have sponsor yet. No VPN sponsor, no CDN sponsor.
Skill learning platform.
Yeah.
No mobile games.
Come on, sponsors. Okay, on to the actual episode. So this week, we'll be talking about testing. I don't have a pun, Afif. I think you had one.
Oh, okay, yeah. So we're gonna start with a pun.
We always do.
Char and Boolean walks into a bar. The bartender says, "Hey, you guys look the same." And then Char says, "Not one bit." Wait. Do you guys get it?
Why is it testing related?
It's not testing related. Yeah, it should have been done before the introduction to the topic.
How is it difference by 1 bit? Because char is character, right? And Boolean is...
No, the Char says it's not 1 bit.
Oh, okay, I get it now.
So we can start the topic now?
Yes, we can talk about testing now. I think why we decided to talk about testing was partially the Martin Fowler article that he recently posted about the shape of testing. On the diverse and fantastical shapes of testing. I'll link it in the description when this episode is uploaded. Basically, he kind of summarizes a lot of different opinions on how modern testing and how the testing pyramid would look like currently. Talk about those for a bit, and then I think he summarizes it in a very holistic way, saying that actually he quotes a tweet by Justin Searles, which says that people can debate on like what type of testing to write and all, but it's a distraction, right? Really, you want the right test that establish clear boundaries, run quickly, and fail for very useful reasons. But I think we can start from there. Should we start from what's a testing pyramid? For those who don't know.
That's a LE5 way to explain it. So imagine a pyramid. Everything at the bottom is probably like the most fundamentals, and then everything on the top built on top of it. In this testing, it also represents the amount we should invest into those kind of tests, and unit tests is at the bottom. At the top is end-to-end tests, if I remember correctly. But it's also the most expensive to test. So you sort of have to have that pyramid as a guide or reference when you want to invest in automated tests for your software product. I hope that explained it brief enough.
Let's break down into all those fancy terms you used earlier. If people are unaware, like what's unit testing, you already mentioned integration test, and what's end-to-end testing. So I think unit test is tests you write to test a single class or single service, or basically a single code file in an isolated way. And then integration test is like having a bunch of these together, test their interaction. When I say a bunch of these, I meant a bunch of services, module functions together to test the integration between them. And end-to-end testing is basically the entire experience from a user point of view. If it's a web app, then it's like clicking on the buttons, see what pops up, matches the behavior of what we want the web app to do. I guess for more hardware-related things, is actually using the hardware.
Maybe we could give an analogy, simple analogy, like a car. Unit test would be something like just test the engine, it works. Test the gearbox, it works. Test the wheels, it works. And then integration is like testing the engine with the gearbox, it works. And then maybe end-to-end test is like just driving the whole car as a test in general.
Arguably, the engine is a very, very huge unit, but yeah.
Trying to simplify it.
There will be like sub-units inside that engine.
Yeah, the throttle body, the EFI, and all that sort of thing.
Yeah, but I think that's a good analogy, Long. It's really kind of like nails the whole thing. I like it.
With that, we want to bring up to what we're talking about just now in the beginning.
Right, the testing pyramid. I wanted to say it's good for us to kind of settle on the definition of all this as well. Different people will have different ideas about it. I think different teams will have different ideas about this as well, especially when you bring in more complex testing, which probably want to talk about, like, regression testing, functional testing, and mutation testing and whatnot. But yeah, let's leave those aside right now. And also, I do believe in formal education, testing is not being taught, right? I mean, at least when I studied in university, testing wasn't a subject. Testing wasn't being tested. Hold on, let me rephrase that. This is a good one. When I was studying in university, testing was not taught and not being tested on.
Okay.
I'm not sure how to read.
Let's impact lah. I had to deliver it a second time.
It's been cushioned by the first impact. Yeah, I had access to some fresh engineers. When I say I have access, I mean I'm in touch with them. Okay, so because I'm helping my friend who's setting up this company, and he has a bunch of junior engineers. These guys are not even out of the university yet. They're doing internship at my friend's company. They don't have all these exposures to tests, let alone CI/CD. Like, if you don't have tests, of course you don't learn about CI/CD and stuff like that. So there is a gap between formal education and also all these industry practices, including testing. I agree with you, like, testing should be part of the formal education because it's basic, essential stuff in software engineering.
I guess to kind of explain what tests are, I mean, we talk about the testing pyramid, then we talk about the type of tests, but we never talk about what is actually testing.
The more self-explanatory term, we should call it automated tests for your software.
But certain types of tests are not automated, so I'm trying to think of an example, but nah. I mean, you could automate majority of the tests given enough engineering effort and time, but I digress. Tests are basically things that you write to check your program is working as intended.
But when I say automated, I don't mean it has to be triggered automatically. I would just say it's run by code. It's not a human behind the test clicking all the buttons and test what's work and what's not, right? So that's what I mean by automated tests. Not that it has to run inside automation triggers or whatnot. Hope that clarifies.
The testing pyramid is probably one of the earliest model that was in this space, right? So it has been taught for a very long time, like, years ago, maybe a decade ago. Somebody came out with something called testing trophy, which is kind of like a different shape. The composition is a bit different. In testing pyramid, the biggest part is unit tests. But then in the testing trophy, they're putting emphasis on integration tests. So there's some unit tests and there's some end-to-end tests, but the whole chunk is on the integration testing. I think this is brought up by Ken C. Dodds, which is a very famous person in this JavaScript world. And I think the argument was that when testing pyramid was introduced, writing end-to-end tests was like really, really expensive. But then nowadays, even though it's more expensive than unit tests, because unit tests take like sub-seconds to run, like one unit test, right? So integration test needs a little bit more setup and then runs a little bit slower. But then it gives you a lot more confidence rather than testing by unit. And there's a lot of other testing models out there. Like, you can find testing hourglass, which gives very little emphasis on integration tests, but then gives the same amount of emphasis on end-to-end tests and also unit tests. There's a lot of things.
Based on all these models, even though they are very different models, but they are still shapes around 3 to 4 consistent tests, right? Which is unit tests, integration tests, end-to-end tests. Right, they always focus around these three. So no matter how, I think these kind of are the three things software developers would invest their time in when they are writing tests. Fundamentally, I think that's kind of what we agree on, right? You want to write tests that establish clear boundaries. For example, when you're writing unit tests, it'll be good just to focus on a single unit, right? So when you're testing an engine, just test things inside the engine. Engine will have fuel going in or whatever methods you have defined for an engine, rather than like, I suddenly have a gearbox object inside my engine unit test. That will feel a bit weird. Could mean that the code itself is tightly coupled, and that's probably something else to look into.
I would also argue that the problem with end-to-end tests, even though it gives you the highest level of confidence, like just now you were saying tests about engines, right? Somebody might argue, hey, why not just have the person drive the car, and if it works, then you can know that everything else is also working. Like the engine is working, the wheels are working, and all of them is working. But then you have to remember that before you have a car, you cannot actually write the end-to-end test. So that's the problem. Like if you're building a new product and you want to write end-to-end test first, you're gonna have a problem because you don't have the end yet. So you'll be writing the end-to-end test right now, and then you realize that you will be rewriting that, and because it's the most expensive test to run, it is also really easy to just ignore and say that, hey, we're not gonna write this now because we're gonna change this again, and then suddenly bugs creep in within that window where you decided to skip. So all of the different categories of testing should be written where it's suitable. I think that's also what Martin Fowler says.
Although I would say maybe test-driven development purists might disagree with what you just said about writing the test later. I'm just saying they might disagree. I'm not saying I disagree. Let's talk about it, I guess. I've never done pure test-driven development. I've never written the test first. Because frankly speaking, when you're working on a piece of software, it's probably written by 10, 20 over engineers over a long period of time. I don't think it's very easy to just say, hey, I want to add this function, I want to fix it, but I'll write this test immediately. Like you have to go in and understand existing behavior, understand what's the existing test, what is the existing test trying to test before making some changes and trying to see what changes. Because for me, the initial part of development is really figuring about if I push this button, what's gonna explode, right? Understanding behavior. I think unless you're working on a pure greenfield project, then it's a bit challenging to do a very pure TDD approach. Like for me, I just try to make some changes, see what happens, keep figuring out until, okay, I kind of, one, understand how the existing code works, two, see how my implementation has changed, because it's like, okay, I'm going to implement it this way, but it doesn't jive well with maybe the overall design or maybe the unit itself, right? And then I'll change it a few times before finally settling down on okay, this is an implementation I'm happy with. Now I'm going to write a test. And then what me personally I'll do is I will try to, after writing the test, make sure it's passed, and try to break the test, changing the code. Because one of ex-colleague mentioned something before, and I still follow it today, say that your test should fail whenever you change a behavior. So the implementation I've gone through the iteration, right? Figuring out how I want to implement this thing, how I want to fix this bug, integrate it into the code, write the necessary tests, and then passing, good. Let me try to change something and see if it fails. If it doesn't, then something is wrong somewhere.
Yeah, I think it's a good point that you should test the behavior, not the implementation. Going back to the analogy, just now, let's say test a wheel, whether a wheel, I don't know, rolls to test a wheel. It doesn't matter if I change some rubber tube somewhere. I'm only testing the wheel is rolling or not at a certain rate. You're not testing whether the wheel has this certain part of rubbers in these positions, right? That's testing implementation. And as for test-driven development, I think other than completely greenfield projects, I only done it once or twice. I mean test-driven development, where I need to write a completely new small modules. That's where I think I can afford to write the test first, because the test is gonna be very small, below 100 lines, something. Only those time I would do test-driven development. For the rest of the other scenarios, Gray, what you mentioned, there's been a lot of codes. If you want to start with the test, then you're working on module without test. You have to test all the pre-existing behavior first, and then you add on to your new test. That's gonna take a lot of time. I'm not sure if we can justify the ROI in terms of time. The time you have to invest to just write the test first before you write any code, I think it's gonna take much longer than you write the test later.
For me, it's the same long. I've only done TDD if I need to add new features, sometimes during bug fixing. So if I know what's triggering that bug, so I just write the test first. It failed. I know that it's gonna fail, and then just fix the code. Then it's green. I agree with what you said also, going it's quite hard to actually do it in a existing project. In greenfield projects where you're just ironing out all the algorithms and stuff, then yeah, maybe you can do TDD. Yeah, most of the time we're not actually in this situation. Usually we're just taking somebody else's project, just collaborating. I know some people will argue that there's always room to do TDD anyway, because most of the time we're just fixing bugs and adding features, right? Those are the two things that we actually do. So I agree that it's easier to do it in greenfield projects.
Actually, another place TDD would really apply is doing refactoring as well. If the business logic is already very clear what the piece of code or service is supposed to achieve, and there's no existing test, or you want to do like a decoupling or refactoring, then starting out with tests makes a lot of sense if there's not enough coverage already, depending on what's the definition of a coverage.
Refactoring is really a good time to do TDD because first, it helps you understand the existing code behavior because you have the understanding to write the test. And second, it really gives you confidence when you do the refactoring. You are not breaking any existing features. That's most of the time where I think TDD makes a lot of sense. Refactoring.
It also goes back to the earlier point that Long made. Be sure to test the behavior and not the implementation details. Because if you're coupling the tests with the implementation detail, it's going to be hard for you to refactor because you're going to ensure that all the implementation details are going to be the same, right? Because you're refactoring. But then the behavior should be the same, not the implementation details.
Yeah, that's a phrase that's been thrown around a lot, right? Don't test the implementation details. But what's like a good example of that? I know Long talked about the wheel earlier. Like, what more concrete examples, I guess, to give people? Like, do I just test the wheel can roll, but I don't care what material the wheel is made up? Is that it? Or
I have one actual example. Let's say we have functions that expect certain input and then give you a certain time format, right? I think I've run into a test that tests whether the underlying library that we use, time library we use, get initiated or not. That sort of test. Instead of testing what's the format that you're expecting from this. So when you change the underlying library from moment to something else, right? Let's say, oops, sorry, moment is a library. So get that way. So the test would fail once you change that library that you used for time, generate that time, right? Even when the given output is the same, exactly the same, the behavior is correct. But why the test fail? Because I changed the library to something else. That's not a good way to write tests because the software is still working, everything is still working. Somehow the test fails because the test was testing for certain implementation of the library, which is a bad way to write tests. That's it.
maybe summarize that in my own understanding is in the test we pass in the input and we just test the output.
Correct. Yes.
One weird thing to ask, I guess. So we write tests, right? We set up some fake object, for example. Okay, so let's say we have a car, right? And then we set a car variable with 4 wheels. At the test, do you test this is gonna sound very weird, I guess. Do you test if the wheels equal 4 or wheel equals car dot number of wheels? Okay, I guess it just doesn't make sense, never mind.
Do you mean like do we test against hard-coded values or the expected value has to derive from another functions?
Yeah. That's why I asked. What do you all think about testing against exact value? Putting the expected result as a hard value or the variable result where it's derived from? Yeah.
I think it depends. I think it's very situational.
I have an opinion that whenever possible, you should test with the hard-coded values. As in, let's say you want to test a function that generates certain HTTP headers, you should just test it against the exact string instead of using another function to generate the exact string headers, right? But what if there's some other tests like what we brought up, situational? What you're expecting changes according to when you run the test or some other variables. I think those are the situation that I think it makes sense to have the expected value generated from some functions or whatnot. As long as the function is not the one that's the same as unique on the test. Because yeah.
You don't want to test back your own mock or fake or whatever, right? It kind of defeats the purpose of testing. I think opposite of what you say, Long, actually. I prefer testing against the fake variable or whatever because it's always like a random generated thing. Rather than like forcing the input to be always fixed, I always put a random input. The output generated should equal to whatever result from the random input. But I guess both of you say it's situational. I think there are probably some behaviors where you need to fix something. So that makes sense as well. I guess this is more a matter of preference, right? If you write the test well, it doesn't matter if the thing changes. The behavior will always be the same.
Gu, you also mentioned a snippet of something that I see often that actually doesn't help when testing, which is testing against your own mock. We're just talking about this like casually, but then it actually happens a lot. And this is...
Sorry to stop you there, but what's a mock? For those who don't know what's a mock.
A mock is basically a replacement for something that is external. So for example, if let's say you're sending an email for example. So you have a service that sends an email. So in unit testing, because you're testing something in Solitude, you don't have access to this email sending service. So you actually mock that service. So you can actually specify it to say, give this output when you receive this input. So this is kind of like a mock service. It tries to simulate what is this external party is doing. I've encountered this bug before when I was working. We had a problem with email sending. It was not sending notifications. So I checked. There is a unit test, but then that unit test is failing to catch the bug. And the reason is because the email service is mocked to return something. So let's say it's saying that, okay, this email service should receive this email object and return 200, for example. It's already been mocked right there. And then in the bottom, we just say, okay, I send you this email. I expect it to return 200. Of course, it's going to return 200 because you said it to return 200. It's a mock service. So it goes back to the point where you have to kind of judge what kind of test actually is more valuable in terms of what you're working on right now. If you're dealing with email service, you know that unit tests is probably not going to cut it. So you probably have to write integration tests. It's going to be a little bit more set up then, but yeah, so whatever kind of test that actually helps you make sure that things are working.
It just reminded me of integration test number 1.
What?
For those of you who don't know, someone in HBO was doing an email integration test in production. So a lot of customers receive integration test number 1 in their email.
Testing in production. The best thing to do.
Just don't do it on Fridays.
So you have time to fix it.
All these testing pyramids always have these 3 different categories of testing, right? Unit test, integration, end-to-end. But then there's actually a lot more kind of testing that's out there that's also important. So recently I was learning about visual testing, for example, visual regression testing, where it actually takes a screenshot of your app and store it. So this is like the baseline. So maybe it takes from the master or the main branch. So it stores it as a baseline. Whenever you open a feature branch, it will take a screenshot of that and ensure that the screenshot still looks the same as the baseline. So it asks you to approve or reject. So for example, if it detects any changes, you have to approve that this is an intended change. So it's kind of like a semi-automatic test, I guess. So you still have to require a human input there. I'm just saying that there's a lot more stuff outside of these 3 main testings. It depends on the kind of project that you're dealing with, I guess. So if it's heavy on UI, like you're building a website builder or something, then maybe visual testing is something that you want to put more focus on. Like others are like, if you're just building like a simple form service or something, then maybe we don't need that heavy UI testing. I guess the shape of the testing model depends on your own project or requirements, I guess. The kind of project that you're doing.
Before I talk about one last thing, do both of you have anything you want to add on? Like to everything you talk about before we start like the one last thing and then we can wrap up.
Like one thing we didn't quite mention, let's say we want to have audience that not familiar with testing to understand is why are we doing automated testing? Like maybe we should talk about that a bit before we close up.
Why we want to do testing? So I think we briefly talked about it when we were talking about CI/CD and all, right? So because you wouldn't work alone on a code base, right? Very often you work with in different teams, and there'll be multiple teams might be contributing to the same code base. So to ensure the code base doesn't stop working, basically put tests to ensure that whenever they write a new service, a new function, a new code, they'll write tests. They'll write a unit test for that specific function and an integration test with whatever they're integrating with, right? So when multiple teams integrate their code together with one code base, it will kind of ensure there's no presence of bugs. Because I wanted to say that there's this phrase, right? Tests can show presence of bugs, but not their absence. So I'm not sure whether my analogy was apt.
It's a way to boost our confidence against shipping something into production. Because when we can know there's no bug. And also you don't want to do manual testing of all the existing behaviors of all the existing specs against all your code base. But after you ship a new features, I guess in a way. Yeah, I guess that's a given.
I wanted to say something snarky about, we always talk about confidence level when it comes to tests, right? But for those people who don't write tests, they're probably super confident that their code base won't break. That's why they don't write tests.
Right. Bugs is for beginners. I don't code bugs.
10x engineers don't code bugs. Therefore, they don't even write tests.
Yeah, you just need 10x QA team.
Oh no, we totally didn't touch QA. Yeah, we should talk about QA next time around. The last thing I wanted to talk about was test coverage, but I think in the essence of time, maybe next time. Right, everyone, this has been the episode. Follow us on Twitter, Kopi Overflow. We are on YouTube and all major podcast platforms, and that includes Apple and Google Podcasts.
Don't get your copy overflow. Make sure you write test for it to test it. It's not overflow.
Oh, that's a good one.
That's a good one.
All right, this has been Kopi Overflow. Thank you, everybody.
Thank you. Bye-bye.
Thank you. Bye.